Welcome to This Explainer. You know when you look at the bottom half of the globe, it can easily feel like a totally random patchwork of extremes. But actually, scratch that. It's not random at all. Today we're going to dive right into this seemingly chaotic diversity of climates across the Southern Hemisphere. Together, we'll pull back the curtain and uncover the hidden geographical forces that are really controlling these drastically different environments. Let's anchor ourselves with this global climate map because it highlights a really fascinating paradox. Just look at the unbelievable contrast in the Southern Hemisphere. On one hand, we have Oceania, boasting these incredibly lush, humid rainforests. Yet, literally right next door, a staggering 70% of Australia is a parched, arid landscape. And if we look even further down south, we hit Antarctica, a massive continent entirely covered in ice that scientists actually classify as a desert. I mean, how does that make any sense? Well, here's our itinerary for today's explainer to figure that out. First, we'll explore Australia's extremes. Second, the tropical isolation of Oceania. Third, the freezing polar desert of Antarctica. Fourth, we'll decode the hidden geographical forces shaping all of them. And finally, we'll wrap up with a quick summary. Let's get to it. Section 1, Australia, Land of Extremes. We're kicking off our journey in Australia. It's a continent famously dominated by a punishingly dry interior. But as we'll see, it's surrounded by surprisingly diverse edges. All right, let's talk about this massive number, 70%. It is absolutely wild to think that 70% of the entire Australian continent is made up of the arid and semi-arid zone we usually call the outback. If you find yourself standing out in this massive interior, you are dealing with blistering heat and practically zero rainfall. It is a harsh, unforgiving desert and xeric shrubland. The only things surviving out here are incredibly hardy plants that have evolved to just take the heat, like saltbush and really tough spinifex grass. But hey, Australia isn't just one giant desert. Let's look at the edges. Up in the northern tropical regions, like Darwin and Queensland, the climate suddenly shifts to distinct wet and dry seasons. This creates vast savanna grasslands dotted with scattered eucalyptus trees. Meanwhile, down on the southeast and southwest coasts, you get this beautiful temperate climate. We're talking distinct seasons, moderate rainfall, and incredibly dense, lush eucalyptus forests. And here's why this matters. That moderate rainfall and those distinct seasons dictate livability. That is exactly why the vast majority of Australians live right on these outer edges instead of in that bone-dry interior. Section 2, Oceania, Tropical Isolation. Moving away from the dry outback, let's cross the water and transition into the wet, tropical isolation of Melanesia, Micronesia, and Polynesia. Now, this perfectly illustrates the crazy contrasts within Oceania itself, the high islands versus the low islands. See, most of the Pacific Islands have a tropical wet climate with year-round rain and high humidity. But what actually grows there? Well, that depends entirely on the land. On the mountainous high islands, like Papua New Guinea, you've got highland climates supporting these incredibly lush, multi-layered tropical rainforests just bursting with biodiversity. But compare that to the low islands. These are low-lying coral atolls. Because they barely poke above sea level, they have to rely on highly specialized salt-tolerant vegetation, like coconut palms and mangrove trees, just to survive the constant ocean spray. But wait, Oceania has another major trick up its sleeve. Down in New Zealand, the climate shifts dramatically to a marine west coast environment. So instead of that intense tropical heat, you get cool summers and mild, super rainy winters. And this unique climate allows for completely unique vegetation. Instead of palm trees, you're going to find sprawling mixed forests and vast tussock grasslands filled with iconic southern beech trees and giant ferns. It is a completely different world from the rest of the Pacific. Section 3, Antarctica, the polar desert. Let's drop the temperature completely and head to our third region. I know, it sounds like a terrible joke to tell someone to pack sunscreen for a massive ice cap. But technically speaking, Antarctica is the world's most extreme desert. It's an ice cap climate where temperatures basically never rise above freezing. But here's the kicker. The defining feature of a desert isn't heat. It's a lack of precipitation. And Antarctica gets almost zero of it. It is fundamentally a frozen desert. And because conditions are so unbelievably harsh, the vast majority of the continent is what scientists call abiotic. That simply means the environment is totally devoid of life. The sheer, crushing thickness of the ice cap covering the continent completely prevents any kind of plant growth from taking root. For thousands and thousands of miles, there is absolutely no flora at all. However, nature always tries to find a way, right? During the super brief summer, right on the absolute fringes of the Antarctic Peninsula and the subantarctic islands, a tiny tundra biome actually emerges. Now, life on this edge is extremely limited. It mostly clings to the rocks in the form of lichens and mosses. In fact, on the entire continent, there are exactly 2 species of flowering plants that manage to survive here: Antarctic hairgrass and Antarctic pearlwort. 2. That is the absolute limit of what this frozen desert can support.
Section 4, Forces Shaping the Climates. Okay, so we've seen towering rainforests, bone-dry outbacks, and totally lifeless ice sheets. So what actually unites these drastically different landscapes?
To truly understand why these zones exist exactly where they do, we need to look at the mechanics. Let's count down the 4 hidden geographical forces that are basically pulling the strings and orchestrating all these crazy climate extremes.
Number 1 is latitude. This is the baseline transition for the whole globe. As you move from the warm tropical equator straight down to the polar south, the angle of the sun changes dramatically. This simple geographical reality creates a massive temperature gradient. It dictates the shift from the high humidity of Oceania all the way down to the frozen 0-degree baseline of Antarctica.
Number 2, the Great Dividing Range in Australia. Remember that 70% dry outback we talked about? Well, this mountain range is the main culprit. It acts like a massive physical wall right along Australia's east coast. As wet ocean air hits the mountains, it drops all its rain on the coast. So by the time that air finally crosses over the peaks, it has literally no moisture left. This creates a massive rain shadow, trapping the rainfall on those livable temperate edges and leaving the vast interior completely parched.
Force number 3, ocean currents, specifically the Antarctic circumpolar current. Think of this as an invisible, freezing, swirling barrier in the ocean that constantly circles Antarctica. It acts as a powerful wall that permanently isolates the continent from any of the warmer waters trying to come down from the north. Without this current, Antarctica wouldn't be nearly as locked in ice as it is today.
And finally, force number 4 is elevation. We saw this perfectly over in Oceania. The altitude difference between the mountainous islands and the low-lying coral atolls dictates exactly what can survive. High elevation literally catches the clouds in the rain, allowing those dense, layered rainforests to flourish in places like Papua New Guinea. But the low-elevation islands, they miss out on that trapped moisture entirely and have to rely on salty ocean water, which means they can only support things like mangroves and palms.
Section 5. Summary, quick identification. Now that we know the 4 forces at play, let's pull all these threads together. This breakdown is your crucial takeaway from today's explainer. It directly links every single region we've toured with its primary climate and dominant vegetation, all driven by those hidden forces. You can see right here how Central Australia's arid climate gives us that tough spinifex scrub, while Northern Australia's tropical wet/dry climate creates savannas. New Zealand's marine west coast climate supports temperate forests. The tropical wet Pacific atolls rely on palms and mangroves. And finally, the extreme ice cap of Antarctica barely supports minimal moss and lichen. It's like a giant puzzle, and it all connects perfectly. So, knowing that these delicate but extreme environments are completely dependent on these 4 geographical forces, it leaves us with a pretty massive question. As global systems and ocean currents, like that Antarctic circumpolar current, start to shift, how might these distinct landscapes transform next? Will the outback grow? Will the ice cap retreat? The forces that shape the southern hemisphere are absolutely still at work today. Thanks so much for joining me on this explainer, and keep your eyes on the map.